Okay, even function. Even function. What is this even function? If at all f of minus x equal to f of x for all x belongs to domain. So, okay, where f of x is real valued function. F of x is real valued function. F of x is real valued function, okay, defined on the domain D, then if at all f of minus x equal to f of x for all x belongs to the domain. So in the domain, whatever if x you take also, if at all f of minus x equal to f of x only if you get, then f is called even function. So for example, what is the example for even function? F of x equal to x square, f of x equal to mod x comma cos x comma sine square x or x to the power of 4 plus x square. These are all even functions. Okay, these are all even functions. Okay, so why it is even function here? F of minus x, if you put in the place of x, if you put minus x whole square, which is x square, which is f of x only. That means even in the place of x, if you replace minus x, then also you are getting f of x. F of minus x equal to f of x. In this case also, f of minus x equal to minus mod of minus x is mod x only. Mod of minus x, mod of x, both same. So here cos of minus x is actually cos x only. So sine square of minus x, sine square minus x is minus sine x whole square. Whole square is there, therefore this also sine square x only. Okay, then next here also if you put minus x power 4 plus minus x whole square, also you are getting the same x power 4 plus x square. That means this is f of x only. So here you can see either in this case, in the place of x, if you replace f of minus x, again you are getting the same function. So all these cases you can see f of minus x is f of x. If at all f of minus x equal to f of x, then what we say is this so f of minus x also, if you get f of x, then we say f of x is even function. Okay, all right. So then we'll go to odd function. Okay, for even graph of even function, graph of even function, graph of even function. Okay, let's see here. So here,
Sir,
simply if you see graph of even function, so even function graph is, so what is that? F of x equal to, let's say, mod x1, and f of x equal to x square also will take 2. So f of x equal to mod x, if you draw the graph of f of x equal to mod x, you know, like this you get. This f of x equal to mod x graph is like this. So what is that? F of x equal to x only. X means this one. This is f of x equal to minus x. For x positive, f of x equal to x. If x negative, f of x equal to minus x. Like this graph you get. That means it is symmetric. This is called symmetric about, see, exactly like this. Exactly like this. Exactly like this. So that means what? Symmetric about y-axis. So graph is symmetric about y-axis. Symmetric about y-axis. Symmetric about y-axis. If at all you see y equal, this also f of x means y equal to x square. So y equal to x square, what you get? This also, if you draw, it is symmetric about y-axis. So this graph also like this. So that means what it is? Symmetric about y-axis. If you see symmetric about y-axis again, so for y-axis it is symmetric about this y-axis. It's all the same. Now if you want, you can see f of x equal to x power 4 also I gave example. So that graph also like this. So this graph also like this. This graph also like this. This is also symmetric about y-axis. And of course, many other graphs also we can see. Graph of even function is always symmetric about y-axis. So like that. So now the odd function. So odd function. What is this odd function? You can guess f of minus x equal to minus f of x. F of minus x equal to minus f of x. F of minus x equal to f of minus f of x. Examples. What are the examples? F of x equal to x, identity function, comma, f of x equal to x cube, x cube. Okay, these are odd functions. So you can see that odd functions. So graph of odd function, odd functions. So some people know that sin x, f of x equal to sin x. Actually, sin x is odd function. Why? Because some people know this. Okay, we are going to learn in trigonometry. F of minus x equal to minus sin x. That is minus of sin x means f of x. So here also, if it all f of minus x equal to, I already told now, f of x equal to x if you take f of x equal to, if you take x, if you take f of x equal to x, if you replace minus here, here also you get minus, first function, minus x. Minus if you keep aside, this is f of x is x. Like that. And also f of x equal to x cube I told. X cube, what is that? If you put f in the place of x, if you replace minus x whole cube, which is minus of x cube, which is minus x cube is f of x. So f of minus x is minus x cube, which is minus f of x. Okay. So therefore, the definition of odd function is, I think you are able to, definition of odd function is f of minus x equal to minus of f of x, then f of x is called odd function. This is the definition. And here f of x equal to x cube, and then sin x, f of x equal to sin x. These are all examples for odd function. So now let's take some graph. Let's go to graph of odd function. What is this graph like? So I told you, what is the first example? Example 1 is f of x equal to x. If you see f of x equal to x, this graph is like this. So y equal to x. No, this is y equal to x graph. 0 means 0, 1 means 1, 2 means 2, 3 means 3, 4 means 4, like this. It will come in the first quadrant and third quadrant. So graph will always come in first and third quadrant. So odd function graph is comes in first and third quadrant. Okay, first and third quadrant. It comes in first and third quadrants. So also we can see x cube graph. F of x equal to x cube graph. This also we can see. What is that? We can this one is like this. X cube graph will be like this. 0, 0, 1, it's 1. 2, it's 8, like this. It will go like this. It will go like this. It is going like this. Actually, it will go like this. And minus 1, it's minus 1. Minus 2 is minus 8. Minus 2 means minus 8, like this it is. It will come like this. So again, it is comes in first and third quadrant. In the first quadrant, it is symmetric about, so you cannot say this symmetric, but in the first quadrant, it will come in the first quadrant and third quadrant, like this it is. That much we can say. This is even and odd functions. Okay. So how do you check a function is even and odd? You have to replace x with minus x and see whether you are getting f of x only or minus f of x. If you get f of minus x, f of minus x, if you get f of minus x is, see, f of minus x is plus f of x, then it is even function. If you put minus f of, if you get minus of f of x, then it's odd function. If If you don't get anything, this is neither even nor odd function. So another function is there. That is that neither even nor odd function. Neither even nor odd function. So what is that? F of x equal to, for example, x square plus x. So here if you put f of minus x, what you get? X square minus x. In the place of x, if you put minus x whole square x square, x is minus x. This is not equal to f of x, also not equal to minus f of x. So therefore, it is neither even nor odd function. So therefore, if a function is given, it must be either even function, or function, odd function, or neither even nor odd function. Neither even nor odd function. Okay, this is what about even and odd functions. Okay, all right. So here we are taking two examples. Question is determine whether the following functions are even or odd. So this function and this function you can just see, and another function is also there here. Since I taught you exponents and logarithms, you can do this one. F of minus x. If you write f of minus x, what do you get? A power minus x minus a power minus of minus x. Minus of minus x. We are replacing x with minus x. Plus sine of minus x. Already I told you sine of minus x is minus sine x. A power minus x. This is minus. A power minus of minus plus x. This is minus sine x. So sine of minus x minus sine x. Now you learn the formula. Later we will know how we got it. Now you take minus common. If you take minus common, what you get? A power x. First a power x we get, and a power minus x will get minus a power minus x, and for sine x we will get plus sine x. Okay, this is what is exactly minus, this is what is f of x. So therefore this function f of x what we got? A power x minus a power, see, f of minus x what we got? In the place of x we have to substitute minus x. Here minus x, here minus of minus x plus x, sine of minus x minus sine x. So what we got here? A power x minus is there, and see here a power x, here plus is there, here sine x plus is there. So here minus we got. So if you take minus, these two terms will be plus. If I take minus common, these two terms will be plus, and this term will be minus. This term will be minus. So therefore, I took minus common. This is a power x minus a power minus x plus sine x. This is what is exactly f of x I got. Minus of f of x. F of minus x is minus of f of x. Therefore, it is odd function. So then we'll go to next. F of second question. F of minus x. I think you can do the second question. You can do. Okay, this also you have solution. I think the second question you can do. Okay, this is third question. Third question. We have to use the logarithm formula. So third question I will tell you. This third question is there. Third question we'll discuss. Third question, we'll discuss third question. All right, what is the third question? Third question is like this. F of x, so f of minus x equal to log of x plus minus x whole square plus 1, this one. So then what I get? Here get like this. Log of minus x, so log of this is minus x plus under root of x square plus 1. Now if you take minus common, then log of negative you cannot write anything. So therefore, what do you think this is? You are not getting f of minus x, or you are not getting f of plus x also. So you may think that it is neither even nor odd, but what we should do is here, what we have to do is we have to rationalize this. So how to rationalize? Log of this is under root of x square plus 1 minus x we got here. This term I wrote first, and this term I wrote second. This is one into this into I have to multiply and divide. This one I have to multiply with root x square plus 1 plus x, and also divide with root of x square plus 1 plus x. Why? Because I have here x plus under root of x square plus 1. Therefore, I am dividing and multiplying with x plus under root of x square plus 1. So what do I get now? By this arrangement, I get in the numerator, I get a minus b into a plus b, a square, that is x square plus 1 whole square, a square minus b square means this is x square, by this is x plus under root of x square plus 1. So what do I get then finally? Log of whole square and square root gets cancelled, x square also gets cancelled, 1 by x plus under root of x square plus 1. Already we discussed log a by b is log a minus log b. Log a by b is log a minus log b. Then what we got? Log a, log 1 is 0 minus log of x plus under root of x square plus 1. So this is what is minus, this is what is f of x. So what we got, this equal to what we got finally, f of minus x. If I do all this, minus f of x. So f of minus x equal to minus f of x. So therefore it is odd function. So this is how you have to do this one problem. This is important model, you can try to understand. So f of minus x we did, in the place of x if you replace minus x, here minus x, here also minus x, here also minus x, then this we get like this. Then you have to rationalize like this. I have to read. So here a, this is a minus b is there. I wrote a minus b. Then I multiplied with a plus b divided with a plus b. This we can do. Multiply and divide with the same term. Then what I get? A minus b into a plus b, a square minus b square. A plus b here. So here square root square gets cancelled, x square also gets cancelled. 1 by is there. 1 by this one we got log a by b, log a minus log b. So log a is log 1 0. So then we get this one. That is minus of this thing is f of minus x, f of x. So this is what is okay. So all right. So then we will go to exercise and see. So first question, what is the domain? We need to find out domain of this function. How do you find domain of this function? We know it is in the denominator. Therefore, square root is there. Whatever is there under root, that must be under root x bracket. This is integral part of x square minus integral part of x minus 2. Because it is in the under root, it must be positive. And it is in the denominator, it cannot be equal. So therefore, only greater than 0. Square root is there, cannot be negative. Denominator cannot be 0. Therefore, it must be greater than 0. So this one is, how do you factorize this one? Let's say bracket x is some n square minus n means here minus 2 is there, minus 2n. Bracket x I am taking as n, simple. Bracket x I am taking as n. So plus n minus 2 greater than 0. What is that? Put bracket x equal to n instead of writing bracket x. So here n if I take n minus 2 plus 1 if I take n minus 2. So like this. So that means what? N minus 2 if I take n plus 1 greater than 0. Already I told you greater than means does not lie between the roots. Does not lie between the roots. Minus 1 and plus 2 are the roots. So this extreme right is positive, this is negative, this is positive. Already I taught you this one. So now what I want is plus. So therefore, what is that n? Here n is less than minus 1. See, n is less than minus 1. This side n is less than minus 1. Or n is greater than 2. What is n now? Bracket x. Already this one we discussed. Bracket x is greater than 2. Already we discussed this one. Bracket x is greater than minus 2 means what? Bracket x is greater than minus 2 means bracket is integer greater than 2. Integer greater than 2 means it starts with 3, 4, 5, so on. If at all you have to get 3, you cannot get 3 if you have x value 2.999 also. Therefore, you must have x greater than or equal to 3. Answer is x greater than or equal to 3. If x is not 3, if at all x value is 2.9999, then you will get only 2. So therefore, it starts with 3. So x belongs to close 3 to infinity. This is one answer. So, but what about this? So bracket x here in this case, bracket x is less than minus 1, that is minus 2, minus 3, so on. So to get minus 2, what is that? So if we have minus 2 means minus 1 point, so here minus 2 means x is, if you have minus 1, it is minus 1, minus 1.1. minus 1.1, then also it is minus 2. Minus 1.2, it is minus 2. So it should not be 1. Therefore, it should be less than 1. So less than minus 1. Sorry, it cannot be minus 1. It should be less than minus 1. Simple. It should be less than minus 1. If it is less than minus 1, then you will get minus 2. That means minus 1.1. Bracket of minus 1.1 is minus 2. All right. So this is less than minus 1. So that implies what? Here x belongs to, in this case, x belongs to minus infinity to minus 1. Therefore, your answer is union of this. X belongs to minus infinity to minus 1 union 3 to infinity. Already this domain thing we discussed, but here this in the only thing is here you have bracket x whole square. You have bracket x whole square. That is the reason we are discussing again. So integral part of x. So you solve as it is, you can solve this. Greater than means does not lie between the roots. Does not lie between the roots. Minus 1 and 1. Minus 1 and 2. That means greater than 2 or less than minus 1. Greater than 2 means what? 3. Bracket x greater than 2 means bracket x value must be 3. If it has to be 3, it should start with 3. So bracket x less than minus 1. Less than minus 1. So less than 1. Minus 1 means what? It is less than minus 1. That's it. If it is less than minus 1, it should come minus 2. Minus 2 means what? Minus 1.1 also minus 2 only you will get. So just less than minus 1. If it is minus 1, problem. After minus 1, so like this now, minus 1 problem. Minus 1.1, okay. That means minus 1.1 also 2. Sorry, minus 1.1 also minus 2. So therefore, this side less than minus 1. So that is how we should do if we have greatest integer function. So please note it down. Okay, this one, log of x minus integral part of x. So x minus integral part of x is greater than 0 because inside log whatever is there, that should be positive. So then x is greater than bracket x. So this is possible only when x is a real number. If you put no integer, then you will get integer 5 equal to 5 get you. So it will not satisfy. This is not possible. So if you put 5.5, 5.6, whatever, then you will get this is 5.6, this becomes 5. So therefore any real number but not integer. So now we'll go to third question. What is that log of? Here two things are there, very important here. This one is a very important one. So we'll do that one. All right, so question number 3. Let's try question number 3. All right, so let's try question number 3. So question number 3 is this. So under root, whatever is there under root, log of log base 10, 3 minus x base x by x. This must be greater than or equal to 0. One thing. And also here log of 3 minus x by x is there. So whatever is there inside log, this much is there. This must be greater than 0 for. So the whole function is there under root. So whatever is there under root, this thing, whatever is there under root, that must be greater than or equal to 0. And whatever is there inside log, this is inside log, this must be positive. If this is not positive, then log is not defined. Whatever is there inside log, inside root, whatever is there under root, whatever is there, that should be greater than or equal to 0. Two conditions in this case. Log one condition, under root one condition. Under root ka condition this. So log condition is this. Okay, all right. So now if you send this 10 this side, then 3 minus x by x is greater than or equal to 10 power 0. That's 1. I already told you this one in logarithm properties. If this base is 10, then this must be greater than 1. This must be greater than 1. And this one is greater than 0. This one, how do you solve? Already we discussed. And this one, how do you solve? You take minus common, then it becomes x minus 3 by x is less than 0. That means we divided with or multiplied with what? Minus sign. If you multiply with minus sign, sign will reverse. So in this case, what will happen? You have to bring x in this side. You bring x this side. 3 minus x by x minus 1 greater than or equal to 1 greater than or equal to 0. X you cannot take that side because x you cannot take that side because x is positive or negative, you don't know. X you cannot take that side. Understand? X you can't take that side because you don't know x is positive or negative. So therefore, minus 1 you can always bring this side because 1 is a constant. So now here again, and this is, now you know how do you solve this one. I already told you, draw number line. What are the roots here? 0 comma 3. So more than 3 it is positive. Already we discussed more than 3 positive, and this is negative and this is positive. Like this only. Already we discussed this one. So less than means what? Less than means negative. Where it is negative? 0 to 3 it is negative. So x belongs to, in this case, what you get? 0 to 3, including 3. 3 is not included. Sorry, this is. And this one, no, we have to solve this. 3 minus x by x greater than or equal to 0. So this becomes what? 3 minus 2x by x greater than or equal to 0. If I take minus common, 2x minus 3 by x. If I take that side, then it will become less than or equal to 0. Less than means lies between the roots. What are the roots? Here in this case, what are the roots? 3 by 2 comma 0. 0 comma 3 by 2. Okay, so now we draw and we see the common. And means what? Common. And means common. First one is 0 to 3, 0 to 3 by 2. So 0 to 3 is here. 3 by 2 is here. So 0 to 3 means this side. Okay, 0 to 3, sorry, 0 to 3 means this one. And 0 to 3 by 2 means this one. 0 to 3 by 2 is this one. Okay, this one and this one. What is the common? 0 to 3 by 2 is common. Therefore, x belongs to 0 to 3 by 2 can be included. Understand, 3 by 2 is included. 3 by 2 can be included. So therefore, 3 by 2 includes it. 0 cannot include. In this case, what can include? 3 by 2 can be included. 0 to 3 by 2. For 3 by 2, it becomes 0. 0 cannot be included, undefined. So 0 to 3 by 2 is your answer. 0 to 3 by 2. So what we did here, whatever is under root, root 1 is greater than or equal to 0. Whatever is there under root, one thing that is greater than or equal to 0. One thing under root